Hello and welcome to the module on multi-level statistical models. By the end of this module, you would have understood the basic concepts in multi-level statistical modeling, the importance of multi-level modeling and the important multivariate techniques to be used. As we all know, most of the crucial scientific, sociological, political, economic and business decisions are made based on the data analysis. Often data are summarized and an appropriate interpretation of the summary is made. However, some data are complex. This complexity may exist for a variety of reasons. Data referring to more than one level often cannot be analyzed using the conventional statistical models. That leads us to the concept of multi-level modeling methods. Let us see what is multi-level modeling. All statistical techniques which simultaneously analyze more than two variables on a sample of observations can be categorized as multivariate techniques. In such cases, the analysis is desirous of determining the association between one dependent variable and several independent variables. The basic objective underlying multivariate techniques is to represent a collection of massive amount of data in a very simplified form. Multivariate techniques are largely empirical and have the ability to analyze complex data. They also help in various types of decision making. It is nothing but a family of statistical procedures that try to come to terms with the influences that are located on different levels. Multi-level modeling is now being accepted statistical technique for handling such data and is widely available in all computer software packages. For example, in the management entrance examination, candidates are administered various kinds of tests, and the candidates who score high total marks based on many tests at the same time are usually admitted to the course. This testing system, though fair, may sometimes be biased in favor of some subjects with larger standard deviations. Multivariate techniques may be comfortably used in such cases to develop norms as to which candidate should be preferred. The important multivariate techniques are the discriminant analysis, factor analysis and cluster analysis. Let us see what is discriminant analysis. In certain situations, it may be essential to study the effects of two or more predictor variables on certain evaluation criteria as listed below. First, either good or bad. For example, while grouping districts based on their sales potential, the criteria of sales potential will be categorized into good or bad. Remember, districts is an entity here, while each district is treated as a member of that entity. The second would be either successful or unsuccessful. For example, while grouping developers based on their successful completion of projects, the criteria used would be successful or unsuccessful. The third is either like or dislike. An example here would be, while preparing an ice cream product for children, the criteria would be either a child likes ice cream or he dislikes it. The fourth would be above expected level or below expected level. For example, while grouping students after a training program, in terms of their enhanced personal skills, the criteria would be above expected level or below expected level. The researcher would be eager to know if the predictor variables discriminate among these groups. More importantly, it becomes essential to identify the predictor variable, that is the independent variable, which is more important when compared with the other predictor variables. Such an analysis is termed as discriminant analysis. Let us see what is factor analysis. Many a times, the number of independent variables used in predicting a response variable are too many. These difficulties result in either increase in the time for data collection, a higher expenditure for data collection, the presence of a redundant independent variable, increase in the computation time to get a solution, or there might be problems arising while making the actual inferences. Factor analysis aims at grouping the original input variables into factors that underlie the input variables. Each factor will account for one or more input variables. After doing a factor analysis, the total number of factors in the study can be reduced by dropping out the insignificant factors based on the criteria as below. First, minimum eigenvalue criteria. If the eigenvalue, that is the sum of squares of the factor loading of all variables on a factor, is more than or equal to 1, then the factor is to be retained. Otherwise, that factor should be discarded. The second criteria is termed as the scree plot. According to this criteria, one should plot the eigenvalues of the factors by taking the factor number on the x-axis and the eigenvalue on the y-axis. Then identify a factor number at which the slope of the line connecting these points changes from steep to a gradual trailing off towards the right of the identified factor number. Such change in the slope on the graph is known as the scree, and the point is known as the scree point. The factors that marked up to the scree point from the origin are to be retained for the further study. There are three main methods of factor analysis. First is the centroid method, second is the principal component method, and the third is the Varimax or the factor rotation method. Now let us see what is cluster analysis. Cluster analysis is a statistical technique used to identify how various units, maybe people, groups, societies, etc., how these can be grouped together because of certain characteristics they have in common. It is an exploratory data analysis tool that aims to sort different objects into groups in such a way that similar to one another within the same cluster, but dissimilar to the objects in the other cluster. The main difference of cluster analysis from the discriminant analysis is that the number of groups and the characteristics of the groups formed in the clustering analysis are not known in advance. Cluster analysis is typically used in the exploratory phase of research when the researcher does not have any preconceived hypothesis or any a priori hypothesis. It is thus purely a tool of discovery. Clustering is done in such a way that it maximizes the association between the objects within the same group while minimizing the association between the groups. The techniques of clustering can be classified into two forms: hierarchical clustering and non-hierarchical clustering techniques. The hierarchical clustering techniques can be further classified into two: the agglomerative method, which is also known as a bottom-up approach. Here, each object is assumed as a separate cluster and then they will be clustered in succession until a single cluster which consists of all the objects is formed. The second one is a divisive method, also known as the top-down approach, in which initially all the objects are included in a single cluster, and then this single cluster will be further divided into subclusters until each object constitutes a separate cluster. In non-hierarchical clustering techniques, an object of one cluster will be permitted to join another cluster, while the clusters are formed using either the agglomerative method or the divisive method. This means that in non-hierarchical clustering, lateral shift of objects is permitted. Let us quickly see the difference between hierarchical and non-hierarchical methods. In hierarchical methods, there is no decision made about the number of clusters, whereas in non-hierarchical methods, we first need to specify the number of clusters in advance. In hierarchical methods, the methodology can be very slow and usually it is preferred with small data sets. Whereas in non-hierarchical methods, the methodology is faster, more reliable and works well with large data sets also. In hierarchical methods, the initial decisions are more influential, whereas in non-hierarchical methods, one needs to set the initial seeds. In hierarchical methods, at each step, one requires the computation of the full proximity matrix, while in non-hierarchical methods, only cluster distances to the seeds need to be computed in each iteration. Let us summarize the module. All statistical techniques which simultaneously analyze more than two variables on a sample of observations can be categorized as multivariate techniques. The basic objective underlying multivariate techniques is to represent a collection of massive amount of data in a simplified way. These techniques are largely empirical and have the ability to analyze complex data. They also help in various types of decision making. Discriminant analysis, factor analysis and cluster analysis are few of the important multivariate techniques. Clustering organizes the data into meaningful groups that are relatively homogeneous with respect to a specified set of attributes. It maximizes the association between the objects within the same group while minimizing the association between the groups. Techniques of clustering can be broadly classified into hierarchical clustering and non-hierarchical clustering techniques. Hierarchical clustering can be further divided into agglomerative method or the bottom-up approach and the divisive method, which is the top-down approach. In non-hierarchical clustering, lateral shifts of objects is permitted. Hope this module has given you a basic understanding of multi-level statistical models. Thank you.